Swayam Prabha. Digital India. Educated India.
Once again, welcome to the second session. In the previous session, I have described basically rock formation, and rock also we have to handle as a civil engineer. Of course, rock mechanics there is a separate subject. There one can learn the different aspect of rock behavior and how rock will be used in different purposes. But our subject is soil mechanics, and we have to handle soil. And now we will start with soil, how that soil actually transform from rock actually, and by different processes. So, soil formation from rock, this is the topic I am going to start now. The action of frost, temperature, gravity, wind, rain and chemical weathering are continually forming rock particles, and that eventually become soils. There are three types of soil when considering modes of formation. One is transported soil. Generally, that under this transported soil, they are gravel, sand, silt and clays, they are generally transported soil. And most soil transported by water. As a stream or river loses its velocity, it tends to deposit some of the particles that it is carrying, and obviously, when it try to deposit, then bigger particle will be dropped first and heavier particles bigger and heavier particles will be dropped fast. And as a result, on the higher reaches of a river, we can get gravel and sand, and on the other hand, on lower or older parts, silt and clays will be predominant. Especially where the river enters the sea or lake and loses its velocity, there we will get only silt and clay. So, I will try to show how this happens. Suppose this is the river flowing in this direction, and this is solid, the dotted line, suppose this dotted line was the original line of the bed of the river, and while flow is taking place, and obviously, this side will be flow will be more, and because of this heavy flow, sometime this bed which supposed to be rock will be eroded, and this will be travelled along with water, and then when the river become deeper in some to the level ground, and velocity obviously will be reduced, and because of this reduction in velocity, these bigger particles, sand, gravels will start depositing first, then later on you will start depositing silt, and close to the sea it will deposit actually the clay. This way actually in different reaches of the river we can find sand, gravel, silt and clay. So, this is actually the formation of soil by weathering process, and what type of weathering is water weathering. Another soil type is loess, which happens actually in the arid parts, and in arid parts of the world, wind is continually forming sand deposits in the form of ridges. The sand particles in these ridges have been more or less rolled along and invariably rounded and fairly uniform in size. light brown wind blown deposits of shield size particles known as loess are often encountered in thin layers. The particles having sometimes travel considerable distance. So, this name is loess. Sometime, as I have mentioned in the previous in the rock part also, soil and rock part, there also have mentioned hard pan. Sometime in the some exam, what is hard pan? So, some question may be there, so or it may have a multiple choice type of question. It will give different description and you have to find out exactly what it is. Similarly, there are different soil how they are forming, based on that typical name is the loess is one such soil type. It is wind borne soil and it is name is loess. So, sometime in multiple choice type of question MCQ, there are lot of description, 4 description will be given and finally, your choice to be description will be given and then finally, option will be given name of the soil and you have to find out which one is the correct one. So, loess like that, some description will be there, wind borne and all. From this description one can find out that this is the loess. So, like that typical soil there are some name. So, one such is loess. Then residual soil, that is one, it is with transported soil, both are wind and water, they are actually transported soil. And this residual soil, this is another soil where this residual soil is what actually the soil will form and deposit there itself, no movement. And for this there is some process will there, that is generally is chemical process. So, these soils are formed in situ. In situ means in the place itself, where the rock itself because of these changes transform into the soil, that is residual soil. So, the form in situ that means it in place itself by chemical weathering and may be found on level rock surfaces, where the action of the elements has produced a soil with little tendency to move. That means, no movement, only because of this volume change or if it is take place because of this chemical reaction etc., only little movement, otherwise chemically it will be converted from rock to some soil, that is residual soil. And residual soil can also occur whenever the rate of breakup of the rock exceeds the rate of removal. So, then some will be deposited there itself, or so that is called also residual soil. If the parent rock is igneous or metamorphic, the resulting soil sizes ranges from silt to gravel. And residual soil, one important residual soil is laterites. These laterites is a special type of soil like loess or hard pan I have mentioned, are formed by chemical weathering under warm, humid tropical conditions. When the rainwater leaches out the soluble rock material, leaving behind the insoluble hydroxides of iron and aluminum and giving them their characteristic red brown color. So, laterite actually it is a reddish brown color and it is quite hard, and it is by chemical weathering this type of soil form. Then next is, as I have mentioned, the 3 types of soil, one is transported, another is residual and third one is the organic soil. The organic soil, these soils contain a large amount of decomposed animal and vegetable matter, and they are usually dark in color and give off a distinctive odor, smell. From the smell itself and color, one can identify whether the soil is organic or inorganic. Deposits of organic silts and clays have usually been created from river or lake sediments, because if it is deposited in the water, then this will be converted into some silt, organic silt and clay type of material for a long time if it is there. Peat is a special form of organic soil and is a dark brown and spongy material, and which almost entirely consists of lightly to fully decomposed vegetable matter, and it exists in one of the three forms. The organic soil can be there in the three different form: completely decomposed, partly decomposed, something that way according to that. And this is one form is fibrous, though organic soil, but is not completely destroyed its structure, original structure, non-plastic with a firm structure only slightly altered by decay. That means, the original organic is totally not altered, still visible, and it will be non-plastic in nature. And next is pseudoplastic. Peat in this form still has a fibrous appearance, but is much softer and more plastic than fibrous peat. The change is due to more prolonged submergence in airless water than to decomposition. The pseudoplastic, this is for longer period, if it is submerged, that happens actually, then this pseudoplastic organic soil can form. And amorphous, this type of peat decomposition has destroyed the original fiber. That means, it is complete decomposition took place and virtually become an organic clay. That means, now we are talking about gravel, sand, silt, clay, how they are different actually depending upon their size. The gravel is when it is a greater than 4.75 particle size, and when it is sand, it is between 4.75 millimeter to 75 micron, and 75 to 0.002 millimeter is the silt, and finer than 0.002 millimeter is clay. So, the amorphous organic soil is organic clay. That means, it is not only decomposed, the particle size becomes so small, it is like a clay, and when this organic clay form in a large volume in a particular site, it is dangerous, but its behavior is very much unknown, and lot of volume change will take place, because of that it has to be handled very carefully. So, peat deposits occur extensively throughout the world and can be extremely troublesome when encountered in civil engineering work. That means, the surface we may find that soil is quite good, but maybe after 2-3 meter there may be a very thick layer of organic clay, and organic clay void ratio is very high. Of course, we do not know, you may not know now what is void ratio etcetera. From the term itself we can visualize that void ratio means presence of voids in the soil mass. Definitely, the soil is not a perfect solid, it is particles, and between the particles are voids, and though organic particles organic clay is a very fine particles, and particles to particles there will be contacts, and those between the particles there will be very fine voids, and since number of particles is very large, then number of voids also very large. So, ultimately the voids present in the organic clay is very high, and because of this high void ratio it is problematic, because when you apply load, then this this voids will be reduced, which result in the subsidence, that means settlement. So, if the in structure is if structure is constructed over a organic clay, we expect a very large amount of settlement, and that settlement has to be estimated, otherwise the building or structure will have face difficulty, or it will not be able to give proper service. So, that is the warning, that if you find anywhere the organic clay, it has to be handled very carefully. Now, engineering soil. The engineering soil, we engineer actually classify the soil in two groups. One is granular, another is cohesive. So, that is what geotechnical engineers, that means we under geotechnical group talking about soil mechanics, we consider soil as either granular or cohesive. Granular soil sometimes referred to as the cohesionless soil, that between the particles there is no cohesion, and formed from loose particles without strong interparticles forces. The when it is a sand or this cohesionless soil, two particles, when they are compacted through this contact, between the contact of the particles, they can do transfer load and all, but since they do not have any bond, then sometime it is easy to separate. Cohesive soils are made from particles bound together with clay minerals, and the particles are flaky and sheet like and retain a significant amount of absorbed water on their surfaces. The ability of the sheet like particles to slide related to one another give a cohesive soil the property known as plasticity, that while sliding over one over another, because of this interparticle force, that is cohesion, we get the plasticity property in the cohesive soil. So, basically in geotechnical engineering, we classify the soil in two groups, major group. One is cohesionless, and that is sand, and another is or sometimes it is called granular soil or cohesionless soil or sand gravel, directly you can mention, and other type is cohesive soil, that is where actually soil particles is very small and it consists of clay minerals basically. And there are many clay minerals exist, and most important clay mineral for which we know lot of characteristics, they are kaolinite, illite and montmorillonite, and out of these three, kaolinite and illite is comparatively not much volume change take place, whereas montmorillonite is highly when come in contact with water, too much volume change take place and more plastic. So, three different types of important clay minerals just I was talking about, kaolinite, illite and montmorillonite, and it exists in the site in different form, different combination, and of course, clay mineralogy is another separate topic. We are not going in detail. We will try to concentrate more on mechanics. So, I will leave it here and I proceed next. Now, this we have discussed rock, now we have discussed soil and how agricultural engineers see the soil, how geologists see the soil, how geotechnical engineers see the soil, we have discussed. And finally, I have mentioned that our geotechnical engineers, generally geotechnical community generally classify the soil as granular or cohesionless and cohesive. And these two now, as I have mentioned at the beginning that soil generally is a material. So, if I ask you that name a few civil engineering material, many of you mention many material name, and I am sure you will miss the soil. Because you may say that it is a steel, you may say brick, you may say concrete, you may say fine aggregates, coarse aggregates, cement, many other name, glass, wood, but you may miss that soil as material, because since we are building everything on it, we are not, most of the time we are not buying separately, we may miss that as tell the soil as material. But it is a very much civil engineering material. In fact, when you buy a land and plan for a constructing any infrastructure, and you have to see the soil quality, and if the quality is not up to the mark, then you will not be able to build directly on that. And in that case, what you have to do, either you have to remove the poor soil from the surface and bring some good soil before constructing the infrastructure or facility, or you can apply various technique to improve the soil to our desired requirement. So, the soil is very much a material, that means you have to know understand the behavior, you have to know many other properties before doing any activities on the soil. So, if this question comes, then you should not miss the soil as a civil engineering material. In fact, this is a major material, civil engineering material. So, now, so what is the difference between other soil versus other civil engineering material? If I see the difference, the broad difference is like that. Steel and concrete is the most important civil engineering structure, perhaps superstructure will be built with this only, and this can be manufactured, both steel and concrete, and can be produced with desired strength and stiffness, and quality can be also monitored. So, this is the other civil engineering materials, whereas when it is soil, soil generally formed naturally, I have already explained, and properties mostly not known, or if it is known, maybe qualitatively known, and it depends on many factors and no control over its quality. That means, I need good soil. So, I cannot say that a particular site become a good site. So, if you want to make a good site, then I have to apply some technique to make it good. So, that means, since soil is a natural material, so it is you have to understand the soil before using it. So, for understanding this soil, basically this soil, entire soil can be characterized mainly by three properties. One is permeability, another is compressibility, and third one is the shear strength. These three things actually you have to see in the different ways by soil mechanics courses. Permeability means what actually? As I have mentioned that soil is a porous media, and through the interconnected voids the soil can pass through. That means, soil can pass through the soil. The ability to ability to move water through the soil, that is actually nothing but permeability, and we do not desire the soil to be highly permeable. Some area, some places we expect permeable, but most of the construction site we do not expect it is too much permeable. So, permeability is a most of the places, most of the cases it is a negative characteristics. So, that means, if you want to choose a site, and permeability characteristics also has to be understood, and it has to be within our desired expectation. And another second part is the compressibility. This is also another very important characteristics of soil. Compressibility means when apply load, how much it will compress or subside. Suppose you apply load onto the ground surface, whether it will just react without any deformation, or it will react and with some deformation. So, that actually give you the compressibility property. For example, if I build a structure on sand or gravel, its compressibility will be something, and if you build on a structure on a clay soil, then its compressibility will be different. In fact, when the that means, if you build a structure on a sand, that whatever subsidence is required or it will undergo, it will happen in a very short time. Whereas, if we build a structure on a clay soil, that subsidence will happen over a long period. And how it happens, that mechanism in fact we will understand through this soil mechanism, the compressibility mechanism or compressibility characteristics of the soil, that will come later on. So, like permeability characteristics you have to understand, similarly compressibility, that means, if you apply load, how it react, how much it will subside, that has to be understood, and through proper mechanics we will discuss that also subsequently. And last and most important perhaps is the shear strength. That means, the soil should be strong enough, like if I take a rod and then I can pull it, and if I pull it, then it will elongate and sometimes it will fail, and it will fail by tensile strength. Similarly, if I compress it, it may also fail, it will fail by compressive strength. So, like that the steel or fail basically in the tensile strength. Since it is a good tensile strength, we use wherever tensile stress will occur, but in soil generally soil fail in shear strength, and you have to determine how strong is the soil in terms of shear strength. If some soil will have very poor in shear strength, some soil will have a very high in shear strength. For example, generally granular soil will have better shear strength than cohesive soil, and so that means, and we have to understand the permeability characteristic, we have to understand compressibility characteristics, we have to understand the shear strength characteristic, and again under this what are the parameters involved, how to determine those parameters, all those things subsequently one by one we will discuss maybe in the subsequent lecture.